Hyperbola.
You have finished the general methods of the three curves. Why don't you switch on your cameras? All of you switch on your camera and let me see what the figures you have drawn. Yeah. Yes, please. Switch on your cameras. Yeah, Sai Kumar. Very good. Very good. 75 Karthik. Where are you, Karthik? Be in your rooms with your stationery and papers ready. Yeah, 101. Very good. What's that? Parabola?
Yes, sir.
So have you finished hyperbola? 99. Very good. Nice. Okay, all of you finished the three figures. Very good.
Yes, sir.
Yes, sir. Yes.
Okay. No. Let the cameras be switched on. I wanted to see. Let's draw parallelly. In today's class, we will have. Let these classes be interactive. I will be drawing on this board and parallelly by seeing it. If you draw in the class R itself, then any nuances or doubts can be clarified very easily. Okay, so let's start the class. Let's respond.
Yes, sir.
Yes, sir.
So meanwhile, you switch on your cameras and sit. Okay, so I'm presenting now. Okay, yeah. So can you see the screen?
No, sir.
Yes, sir.
No?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So in today's class, we will be dealing with the special cases, or otherwise called as special methods of drawing these conics. So till now, so far, what we have seen is we have seen the conic sections, three conic sections in general method we have seen. General method. So in this general method, we have drawn our ellipse, yes, parabola, and hyperbola. All these three curves we have drawn in this general method. So what does this general method refer is? This is a standard method, a standardized method of drawing these three curves. So what is required? What data is required for construction of these three particular curves in this general method is you need eccentricity, because it's in an equation form, right? So the generalized equation form or mathematical form from which we can recognize the curves, whether it's a circle or an ellipse or a parabola or an hyperbola. So through that equations, if we wanted to represent them in a graphical way, we try to represent it by this general method. So the important thing required there is your eccentricity and your vertex distance and focus distance and all. So all these we get it from the eccentricity as well. So this can be remembered in another way. In an examination point of view, if a question is asked to construct either of these three conic sections, and they ask you giving the following data of eccentricity or directly as a vertex or a focus, the distance between the focus and the vertex and so on, then you can easily identify that he is asking you to construct these three conics in the general method. So this way also you can remember. So this is about your general method. Now what about the special methods? Special methods are those methods which are intended to draw your conic sections, ellipse, parabola, and hyperbola in three separate ways. So these are customized ways of construction. And what is important for the special methods? The major thing required is the major axis and the minor axis. So in other way, or in other words, we can also recognize or remember in the examination point of view, if asked in the question to construct either an ellipse or parabola or hyperbola, by giving your major axis and minor axis, then you can understand that this is one of the special methods he is asking you to construct. Unless if he asks with given eccentricity or vertex or focus, then you can understand that he is asking you to construct it only in general method. So in the general method, you cannot construct with the major and minor axes, and you cannot construct with special method with the given eccentricity. So this is thing you have to remember the most to avoid confusion. So now what's this major axis and minor axis? Can anyone illustrate what's this major axis and minor axis? Where do you find? We should be able to locate it on the ellipse, right? So suppose this is an ellipse we have taken. So on the other day we were discussing about this, the plotting of different points, where this is called your directrix line. You have a focus, this is the center. You have two focal points or focus points. This we have identified, right? This is the directrix. You also have a vertex. Sorry, this is the vertex. Yeah. So please tell me, where do I find this major axis and minor axis?
Sir, major and minor axis converge at center, sir.
Yeah, right, very right. If this is a center, now I will draw a line from the center. Now I'll draw another line from this center. I'll change the color for your sake. Now, can this be a major axis and minor axis?
Yes, sir. Depending upon the major and minor axis, four figures we can draw, sir. Ellipse.
Four figures.
Like H and K, sir. Two figures are based on H, comma K, and two figures are based on A greater than or B or A less than or B.
Yeah, right. Yeah, very right. When we are intended to draw a closed figure of a circle or an ellipse, if we wanted to draw a circle, also you have a major axis and a minor axis, where your major and minor axes are the same. You can simply construct, joining the edges of your axis, you can simply construct the particular figure you want. So these are the closed curved surfaces. So what are the closed curved surfaces that we get? One is circle, other one is ellipse, and what else? Different kinds of ellipse of different eccentricity. So anything, any closed circular figure or any closed curve that we wanted to draw, that can be drawn using your major axis and minor axis. And the longest path that is covered to connect your circle inwards, this is called your major axis. And the shortest path, again from the same center, perpendicular to your major axis, will be your minor axis. So this is the way your major and minor axes are located in your particular curves, conic curve. So first we will be dealing with this ellipse, special methods of ellipse. There are many methods that are used for construction of ellipse that is used, that can be used in different applications, you know. And the same way you have different ways for parabola and different ways for hyperbola as well. So what we are dealing in our syllabus, what are the methods that we are going to learn for construction of ellipse through special methods by given major and minor axes are: the first one we are going to draw is oblong method, otherwise called as the rectangular method. Next one is concentric circles method. You people can note it down. And third one is the arc method. Yeah. Also we have parallelogram method, where your figure is almost similar to your oblong method, but where the difference between rectangle and parallelogram come into picture to draw the difference between these two. So we will go one by one. For ellipse, these are the three methods included in your syllabus. And whereas for parabola, there are again two methods, and for hyperbola, there are again two methods. So in this, all these come under your special methods. So general construction of ellipse, parabola, and hyperbola by general method, construction of ellipse, parabola, and hyperbola by special methods. And in these special methods, you have three special methods for ellipse, two special methods for parabola, and two for your hyperbola. So these are the things we are going to discuss in these conic sections. So first, let's start our today's class with this oblong method, or otherwise called as the rectangular method. Is it clear? Yeah, please respond.
Yes, sir.
So let's construct our ellipse by oblong method, or otherwise called as the rectangular method. Why we call it as the rectangular method is we construct the ellipse by constructing a rectangle first. So we try to inscribe our ellipse, inscribe our cone inside this rectangle. So that's why it's called as a rectangle. So the given data for this is your major axis. Let's suppose it to be 90 mm, and your minor axis is 50 mm. So with this given data, we have to construct our ellipse. So how to construct this? So first, let's take the major axis of 90 mm. So with 90 mm or 9 centimeters of distance, let me draw a straight line. Okay. So mark the center for this, and with this center, did you mark the center? Yeah, this is the center. You draw a minor axis of 500 mm.
Sir, your voice is not somewhat clear.
Right?
It's not clear, sir. Sir?
Yeah. Is it clear now?
Yes, sir.
Should I speak a little bit louder?
Yes, sir.
Is it okay now? Is my voice clear?
Yes, sir.
Yes, sir.
Hello? Yeah, okay. I'm continuing then. So this is how I have drawn my major axis and minor axis. Now what next? This is your major axis AB, and this is your minor axis CD of 50 mm, AB of 90 mm. Now what to do? Now we have to construct this rectangle around your major axis and minor axis. So how to construct this rectangle? Place your scale on point A. Or similar to your minor axis. Minor axis is of length 50 mm, right? So with the same distance of 50 mm from point A, you draw a line, a parallel line. Similar way, from point B with the same length of 50 mm, you draw a parallel line. Now, tilt your scale. What is the major axis? Major axis is of 90 mm. So with the same distance of 90 mm, or simply you can join both the ends, it becomes 90 mm almost. So this is your 90 mm and this is your another 90 mm. Yeah, okay. So this is how I have constructed a rectangle around my major axis and minor axis. Now what to do? Calculate this distance. Now I will name this. I'll also name this box, rectangular box, as 1, 2, 3, 4. So clear dimension or labeling will be clear for us to understand by calling it with names. So now I have my 1A. This is the distance of 1A. What is the length of 1A?
2.5 centimeter or 250 mm.
2.5, sir.
2.5 centimeter.
2.5. Right.
Yes,
Yes,
sir.
sir.
So my 1A is 2.5. What's the unit?
Centimeter.
Centimeter.
Okay, centimeter. Now I will divide this distance of 1A, 2.5 centimeters, into equal parts. So how many equal parts should I divide it will be dependent on me. So I can divide this into 10 equal parts, 5 equal parts, 3 equal parts, 4 equal parts, whatever. But it should be so much clear for us so that more clumsiness of lines should not be there. Got it? If you have more number of divisions, then you will have the curve in a more smoother fashion. If you have a very less number of divisions, then you will not have accurate curve. There can be a mismatch in frequency of your freehand. So in between, I divide this into 4 equal parts. So I wanted this to be divided into 4 equal parts. So for this, what I have to do? What I have to do? Yeah, please. 2.5 centimeters, I have to divide it into 4 equal parts. What is the length that I have to divide it into?
0.625.
Yeah, how did you get that?
2.5
Divided by
4.
what's that? 0.625.
625.
Okay. So with 0.625 you have to divide this, or else there is also one method where you can divide your line very easily. So here in this particular case, you can divide this line by 0.625 centimeter distance, or else there is also another method which I am going to tell you now. By either of this method, by using either of this method, you can construct the particular division, or later on the ellipse. So how to divide this into equal line is just from this point 1 to A. From this 1 to A, you wanted to divide this line. So from 1 you draw an inclined line less than 45 degrees approximately. Let's draw it perfectly. The scale. Some line of some distance. Okay. Now what next? I have to divide this into 4 equal parts, right? So with 1 unit or 1 centimeter distance, you can divide this line. That means from this point onwards, mark a distance of 1 unit. 1 unit comes here. Next from here, another 1 unit. Or else it's 1 unit is equal to 1 centimeter. Okay. Because we are dealing with centimeter. The units we are dealing here is of centimeters. So this is 1 centimeter, this is 1 centimeter, this is another centimeter, this is another centimeter. Finished? 4 equal parts. 1, 2, 3, 4. So forget about the rest. So this is your final part. So this final part has to be drawn. So up to which extent we wanted to divide? Up to A, right? We wanted to divide the line up to this part A. 1A has to be divided. So the final plotting of your point, the fourth division point, should be joined with your final length end of the line, which is this. Which is this. Next, take your scale. This you have to do it with your set square. Set square gives you your exact parallelness. If you wanted to draw any parallel line, a line taking a reference of a previous line which is parallel to it, then you have to use your set square. You have to adjust your bigger set squares in such a fashion that one set square is all along your line and another set square is running across this set square, so that you get parallel lines. So here with the scale, I will show you. Just draw with a roller scale also, you can do it. A scale with a roller backside. With this roller scale, just move it front up to this point and draw a straight line. Next, again move it parallel again to this point and draw a parallel line. Next, move it again to this point and draw a parallel line here. Finished. So these are the 4 divisions that you have drawn.
Sir, once again you will repeat, sir.
Sir, once
You
again,
drew
you
the
can
line.
repeat how to divide that line in 4 equal parts.
Yeah. I'm naming this with PQR. First, let me do this. So the distance becomes PA. Okay. Now, again, what I have done is, I have taken an angle less than 45 degrees from this edge. I wanted to divide this line of PA into equal parts. How many equal parts? 4 equal parts. So 4 equal parts I have to divide it. So that what I have done, I have taken a line less than 45 degrees line from this point P approximately up to some distance. I don't know what is the distance. Simply I have drawn some line. Okay, leave it. Next, on this particular line, what you do is divide this line into equal parts. How will you divide this line into equal parts? By simply giving it a distance of 1 unit or 1 centimeter. The same unit of which you wanted to divide. So 1 unit from here is 1 centimeter. 1 centimeter, 2 centimeters, 3 centimeters and 4 centimeters. Because I have to divide this line into 4 parts, I have divided this into 4 parts. That's all. ఇప్పుడు this PA should be divided into 5 parts అనుకోండి or 6 parts అనుకోండి. అప్పుడు what I have to do? I have to divide this line also into 6 equal parts. So how many parts this PA should be divided? I wanted it to be divided. The same parts this line also should be, this inclined line also should be divided. So keep this in your mind.
Sir,
Now, yeah.
we can do it that from Q side, sir.
From which side?
From Q side, I haven't. I don't have any place from my left
QB.
side.
QB side.
No,
QB
no,
side, sir.
no. For PA to be divided, you have to do it on P. Again, the next part of your diagram wanted to be divided for QB also. Your QB also should be divided later. Appudu you have to draw a line from Q and you have to divide the QB. If PA ni divide cheyadaniki you have to draw a line from P only. Similarly, from RA should also be divided.
Sir, as per your figure, if we take 1 centimeter, it is exceeding A, sir.
Yes, sir. Exceeding A.
ఏంటండి మళ్ళీ చెప్పండి.
Then how can we draw the lines, sir? Sir, you said which, suppose name that as some PS line, sir. Hello, sir.
Yeah, PX. Now what's exceeding beyond A? What you are telling, I'm not understanding.
You said plot 4 points which are of distance 1 centimeter in PS line.
Yeah.
Yeah. When we are plotting the 4th point, is there na, sir? It is exceeding A.
It is
Take
exceeding A.
0.625.
Okay, no problem. Let it exceed. Okay.
Then how
I'll erase
to
and I'll
plot?
show you once again. I understood what your confusion is. Let's draw through your confusion only. I have drawn some line here. PX, right? Now I wanted to divide this line. So say this is your 1 unit. This is your
Sir,
1
it
unit.
should be less than 45 degrees, na, sir? Okay, you took 53 degrees.
ఇప్పుడు ఇలా వస్తుంది అంటున్నారా మీరు?
Sir, I'll show you, see my screen, sir, once. Sir, this point is there, na, sir? 4th point. Here. Hello, sir.
Yeah, no, just see my figure. I wanted you to understand this. This is your 4 dash, this is your 3 dash, this is your 2 dash, and this is your 1 dash. Is this the doubt you are having? This is your 2, this is your 1, this is your 3, and this is your 4. So your 4 is going beyond your A. This is your doubt. Am I right?
Yes, sir.
So here what you have to do, just draw the line. Simply you have to remember one thing. wherever this reaches your fourth point, let it be your fourth point, let it be here downward somewhere. But that point should be joined with your end of your line, edge of your line. The other end of the line should be joined with your final part. So here, as you people said, your point has come here. So simply you join this point to your final figure. Now your parallel lines will come accordingly. Take your roller scale or your set square in such a way that it is parallel to this, and whenever it reaches the point 3 dash, stop it. From 3 dash you draw a line so that it intersects your PA here. Next, take your roller scales where your 2 dash comes, just stop it. Now you draw it where the intersection point of PA comes. Now take your scale to your 1 dash, stop it. Draw a line parallel where it intersects your PA somewhere. Now these will be your intersecting points. Simple.
Sir, we should take that line px less than 45 degrees or more than 45 degrees.
Less than 45 you take it.
Okay, sir.
Okay, is it clear?
Yes, sir.
So I will erase this to avoid confusion. So now my points of
Sir, I'm not
one.
able to arrange the set squares, sir, parallelly.
Yeah.
How to arrange set squares, sir, parallelly to get parallel lengths?
How to arrange your set square is, suppose this is your line. Place one set square in this way. This is your set square, one of your set square, right? So this edge of your set square will be all along your line. So you will have another set square this way. Two set squares. Now put this set square here. It becomes like this. Okay, so now you hold it. You hold it with your left hand, you hold this set square, one set square along this line, and with another hand, you move your set square, the second set square, in such a way that it is parallel to your A. ఇలా పెట్టండి ఆ సెట్ స్క్వేర్ ఈ ఎడ్జ్ ఈ లైన్ డ్రా చేసిన తర్వాత నౌ మూవ్ యువర్ సెట్ స్క్వేర్ దీన్ని ఇలాగే కాన్స్టెంట్ గా పట్టుకోండి ఈ ఫస్ట్ సెట్ స్క్వేర్ ని కాన్స్టెంట్ గా పట్టుకోండి అప్పుడు ఈ సెట్ స్క్వేర్ ని సెకండ్ సెట్ స్క్వేర్ వాట్ యు హ్యావ్ దిస్ సెట్ స్క్వేర్ యు మూవ్ ఇట్ ఇది ఇలా మూవ్ చేస్తే ప్యారలల్ గా ఇక్కడికి వస్తుంది అప్పుడు యువర్ పొజిషన్ విల్ బి లైక్ దిస్ అప్పుడు ఇక్కడ డ్రా చేయండి నెక్స్ట్ దీన్ని అలాగే ఇక్కడ మూవ్ చేయండి యువర్ పొజిషన్ విల్ బి లైక్ దిస్ ఇలా వస్తుంది సో అలాగే ఇక్కడ ఇలా పెట్టండి ఓకే Is it clear? The person who has asked it out. చెప్పండి బాబు, క్లియర్ అయిందా? If people are not responding, hello?
Yes, sir.
Yes, sir.
I'm trying, sir.
Yeah. Now what we have to do, we have to divide this. Which one? PA we have divided. Similarly,
QB.
AR also should be divided. How to divide
Yeah,
AR?
okay.
Any one of you?
Draw a line upwards in 45 degrees.
Understand? Simple, very good.
Same from down to up.
So from R, I have drawn some line, some inclined line. Now divide this line into equal part. The final part will be here. Draw a parallel line. Now the other similar points which are parallel on this line, then your points will be like this. Somewhere approximately I'm marking it. You have to do it accurately with scale. Now these points will be four, 5 and 6. Okay. Now this is your center O, where your major axis and minor axis meet. This is your point O. Similarly, your AO also should be divided into equal parts. How many equal parts? Again, same. One thing you have to remember here in this entire method, the first division of PA, how many parts we are dividing it, the entire diagram should be divided into same equal parts. It's not like you have divided PA into 4 equal parts, AR into 3 parts, AO into 2 parts. It doesn't work that way. If you have divided your PA into 4 equal parts, then your AO also should be divided into 4 equal parts. Your AR also should be divided into 4 equal parts. So this you should remember in your mind. So AO, I will divide it into equal parts. So what is the distance of AO? AO is, yes please.
4.5 centimeters, sir.
Very good, 4.5 centimeters. Now divided by 4 equal parts. What do you get? 1 point. What do I get? 1 point. 4.5 by 4. Why are you not answering?
1.125, sir.
1.125
25
centimeter.
centimeter.
See, one important thing with common sense you have to think is, here we got these points into decimals, 3 decimal, 4 decimal, sometime we get 2 decimal. So if your part, you cannot divide your line because the normal scale that you are using, the centimeter scale that you are using, you have generally with millimeters and centimeters. So with which you cannot divide 0.3 decimals or 0.4 decimals. So when it becomes difficult, then you take the option of dividing the line by this method, the method which I have shown you earlier. But if this is dividend into wholesome parts or an whole number, then directly you can divide the segment into such equal parts. So if suppose this is 2.4, this particular distance is 2.4 instead of 2.5, it is 2.4. Then what do you do? 2.4 by 4, simply you get 0.6. 0.6 can be divided on your normal centimeter scale. Yes or no?
Yes,
Yeah,
sir.
yeah, 0.6 millimeters can be easily located on your centimeter and millimeter scale. So in such case, that you can simply mark your PA line where your 0.6 come, there you can mark it. Again, 0.6 from there, 1.2, then 1.8, and so on. You can mark. You can go on marking that way. But because here you have only one decimal, one number of the decimal, and which is can be easily located on your centimeter millimeter scale. But when the decimals are farther and you cannot locate on your scale, then you can divide the line by this line division method. So that's the important thing I wanted you people to notice and understand. And after doing this 1.125, still we don't have any option. So we wanted to divide this into equal part once again. So how do I do that? Yeah, please tell me, how do I do that? AO should be divided into equal parts. How do I do that? Am I doing it right?
Perpendicular bisector. Sir, we can divide using perpendicular bisector in two parts, then that two parts into two equal parts.
Okay, that way also you can do it. But it takes a little bit time, right?
Yes, sir.
Yeah, it takes a little bit of time. You are from C3. Paper also you got it? Yeah, someone came. So yeah, what one of your friends, what he said is, we can draw perpendicular bisector of AO, you can draw a middle line, then you can draw a perpendicular bisector from there, you can draw another line. But if it takes less time than compared to this, then you can do that. There are many methods for dividing this line. This is one of the methods. So whichever method is comfortable for you, whichever method makes time smart for you, then that method you can adopt. No problem. Only thing is that whatever method you apply, you should be able to complete your figure in the given time in the examination finally. That is very important. So by that time management, you can do whatever you want. Okay. So that's also one of the very nice method, dividing it with perpendicular bisectors. You can adopt. If you can do it faster than this, then you can do it. No problem. So here we try to learn a new method here. I am showing you this method. So simply I draw a line. I divide this into equal parts. So 1 dash, 2 dash, 3 dash, 4 dash. Now what I do again, I take a scale. With this 4 dash, the last part, to the end of your line, edge of your line, I keep a scale or your set square. Position your set square in such a position, such a place, and then you simply draw a line. Next parallel line here, next parallel line here, another parallel line here. So that I got the line divided into equal parts. So I'll place these parts here, and then I erase this to avoid complexness or confusion. Oh, sorry. Okay. So this, I divide this in this way: 1 dash, 2 dash, and 3 dash. The labeling here also I can change it. I'll tell you why I'm changing in this way. This also I will mark it as 1, 2, and 3. So I have marked it in a convenient way such that my 3's are nearer. See this, observe this. I have divided this into 1, 2, 3. 3 has come near A. 1, 2, 3. This 3 has come near A. And 1 dash, 2 dash, 3 dash, whereas 3 dash is also nearer to your A. So why I have done like this, you will come to know. So okay, come after having this done, after dividing your lines into equal parts, we have taken a little bit of time here for you to understand a new method of dividing a line into the equal parts. Generally, it doesn't take this much time if you are evident, or if you get your hands free on that. It takes a very little time. So what I do is, with another color, I will draw a lines. I will join this one dividend points with your minor axis end and call them as C1, C2, and C3. Okay, so the all is converged at one point, which is called as C. Now what I do with another color, I change the color. You can do it with the same pencil, but for you to understand, I have taken different color. So one thing you have to remember here is the minor axis is C and D. So when I have joined the lines of divisions on the rectangular box of one quarter part, that has been joined with your end of your minor axis. See, C1, C2, C3, I have joined this with your end of your minor axis. Now I have to intersect these lines. How do I intersect these lines? I will intersect these with the other end of the minor axis. What is the other end of the minor axis? It is D. So with this D, I am going to intersect it via the points that I have divided it on the major axis. So I am intersecting it with the end of your minor axis via your division points on your major axis, such that when I draw a line from D3 dash, it has to be somewhere. Later on we will change the point, no problem. It should be like this. Okay, I'll change initially. See what was the problem is, ఇలా పెట్టుకుందామండి, అంటే for us to understand more clear, 3 dash, 2 dash, and 1 dash. Now what I do is the same thing. From D, I am joining your 3 dash. So from D, I am joining your 3 dash and extend this line D3 dash in such a way that it intersects the line C3. Generally, confusion will be up to which part I have to extend it. So I have extended it to the point where it intersects your 3 line. The line which is passing through 3 dash is intersecting the line 3. So for that reason, I have taken all these 3, 3 dash and 3 at one part. Okay. So now mark this point. Similarly, D2 dash should be joined. D and 2 dash should be joined and extend it in such a way that it intersects your C2 line. See, 2 dash is going and intersecting at 2. D2 dash is extending and intersecting at C2. Stop there. Mark a point here also. Similarly, your D1 dash, also will be extended. Extended up to which part? Up to the part where it intersects your C1. So this is your C1. Okay, clear? So we got 3 points. We name these points as P1, P2, and P3. Now what next? Same thing we have done from C. The same thing we should also do from D. What's it the same thing? The same thing is this. We are joining a line from points D to the intersecting box, the other quarter box of the rectangle besides D, that is 1. So D1. Next D2. Next your D3. Okay. Now I have drawn lines from D1, D2 and D3. Now how do I intersect them? Any guesses?
From C to
Yes,
3
very
dash.
simple. Right, very good. So from the same other end of your minor axis, from C, draw lines which intersect C. From C, I am drawing a line up to 3 dash which extends up to C3, D3. Now from C, I am drawing a line up to C2 dash and extending it up which intersects D2. Now from C1 dash, I am drawing a line which intersects at D1. Okay, now name this as P1 dash, P2 dash, and P3 dash. Clear? Now, simply join. We know that our ellipse touches the points edges of your major axis and minor axis. So C and D are your minor axis, A and B are your major axis. So your ellipse edge will be touching your point A and point C and point D in this left side part. So to finish that curve, you need 3 more points. If more points are there, it's more comfortable. But see, for these 3 points, we have so much of clumsiness here. If we have more points, we will have still more complexness in understanding which line should be joined to which line. So in that case, what we do, that's the reason we have divided simply into 4 equal parts. So simply join with your P1, P2 and P3. A, P3, P2, P1 and C should be joined simply. So C simply shall I do that with red? So this way, quarter part of our ellipse is done. The other quarter part, A3, P2, P1 dash and D. Here. So with this pen, it's a little bit difficult for me to draw. So roughly I have tried my level best. So this is the first half of your ellipse that is done. Now how to do the rest part?
Same, sir. How we did for PR,
Same.
we should do with QS.
Yes, very nice. So what you have to do is divide your QB into same parts, same 4 equal parts, or simply another shortcut. I can say it's a shortcut. What's the shortcut is, with the scale or your set square, you just measure the points. How to measure the points? See, already you have done here. You have divided your PA. So again, instead of drawing any line from Q and dividing your QB into equal parts and wasting your time, simply by keeping a scale, you can mark the distances here. Right? Is it a shortcut or not? Please respond.
Yes, sir.
See, simply I have done this. And after doing it, what I have done, I have drawn a line. Simply I have taken a line, a very light line for my reference. So you can do the rest in the similar way. Will you do it?
Yes, sir.
The same divisions of A3 dash 3 to 2 dash, the distances what you have taken, the same can be marked here also with the line distancing method. And after having marked these, just join it. Oh, sorry, I have done with the wrong pen here. This should be blue. Now this with green. Okay. So the same on the other side. Finish off the curve. I'm doing it simply, don't do this. You have to draw the other box also. The same similar lines, you have to draw it and join them. Then you will get the complete figure. Now this red curve looks like an ellipse. This is your construction of ellipse by a special method called as oblong method or rectangular method. Okay, is it clear? Yes.
Yes, sir.
Hello. So you people are drawing it parallelly along with me?
Yes, sir.
Are you drawing it fairly or you are drawing it in a rough? Drawing it in your observation books?
A4 sheets.
Please respond. Hmm?
A4 size sheets, sir.
Okay, no problem. Do it in your A4 size sheets. We will go on to the second method. Second method, which is concentric circles method.
CR.
Yeah, someone is talking. Yeah, please say. And now, so concentric circles with the same measurements of given major axis of 90 mm and minor axis of 50 mm. So first draw your measurements. Draw your major axis first. Next, mark the center. We'll change the measurements here for our comfort. 1, 2, 3, 4, 5, 6. This is your center point. So from here, the rest. Place this in the center. Your first half of your minor axis from here, and the rest from here. This is a way to draw your major axis and minor axis given measurements. Now, what next? Now you have to draw a circle. What is meant by a concentric circle?
Sir, center is
Hello?
same but different radii.
Yes, very good. So here we got the opportunity of drawing a concentric circle. We have got the same center, but we have got different radii. One radii is A, B, C, and D. Say this is O. So one center, one radii is OC, the other radii is OB. Simple. So draw a circle. Draw a circle with COC as radius or OD as radius. Both are the same. So when you draw a circle, okay, I tried almost to look it like a circle, but excuse, the other circle also I'll draw. I'll draw with OA as radius. Okay, so I have tried drawing it a circle. You draw it with a compass, you'll get a very smooth circles. There's nothing to worry. Very simple drawing. But try to understand it here. This odd drawing. Now what next is you just divide this circle into equal parts. Now how to divide a circle into equal parts?
Sir,
Hello?
join AC means A, B, C, D. Yeah. Sir,
Pardon? Join A?
mark one more point, sir. Up of C.
No, yeah, that's what. How do I do that? My question is, how do I, whatever circle it may be, whether it's CD diameter circle or AB diameter circle, how do I divide this into equal parts? A circle can be divided into equal parts. Can it be done?
Line passing through center.
Can a circle be divided into equal parts? Hello?
Yes, sir.
Yes, sir.
Yes,
How do we do that?
with the help of diameter. It's AB. The bigger circle is already divided into two parts, and the both circles are divided into two parts, no, sir.
I wanted this to be divided into 12 equal parts. Bisect with an angle. Simple. Yes or no? Can it be done with bisecting an angle? Hello?
Yes, sir.
Yeah, simply outside, if you see any person who is selling this jamun, Goa, how do you do that? Simply he cuts in the middle, next perpendicular to that, next 30 degrees angle, next 60 degrees angle. When he cuts, we get 12 pieces. Did you observe?
Yes, sir.
Yes, sir.
Yeah, so similarly, the CO radius circle can also be divided into 12 equal parts with the help of your bisecting with an angle. So take a protractor and you can see the COB line is 90 degrees. So place your protractor this way. ఇలా పెట్టేయండి protractor. ఇప్పుడు ఏంటిది? This is your 90 degrees. అంతేనా?
Yes, sir.
This will be your 60 degrees. This will be your 30 degrees. This is your 0 degrees. So simply mark these points, position these points, take a scale and join them. So while you join them, join on the other end of the circle also. Like this. మరి రెండు అవ్వాలి కాబట్టి పైకి కిందకి below your xy center line and above your xy center line. Both the lines cut. Draw the bisectors cutting these lines. So similarly on the other sides also I am doing it. So similarly here also you mark your 30 and 60 degrees angle. And simply we have divided this into 12 equal parts. Okay. The outer circle is divided into 12 equal parts and I have labeled it. Now the same thing you do with the internal angle also, internal circle also. So how do you mark it? You mark it with 1 dash. Where is this line is intersecting your inner circle, you mark it as 1 dash. In the outer circle you have marked it as 1. Similarly, in the outer circle you have marked it as 2. So this becomes your 2 dash. This becomes your 3 dash. 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash and 12 dash. Now, are we done here? Any confusion up to this part? This should not
No,
be. Hello? Yes, is it clear? Say clear so that I'll proceed.
yes, sir.
Yes, sir.
Okay. So here also we have to understand that our ellipse starts from edge of your major axis and minor axis. So your point A, point C, point B, and point D are touching your ellipse. So you need to have the other two ends. You need to have the other two ends to be touched. Third section. Paper also have kept. There. Please wait for 1 minute. Okay. A door is వెళ్ళండి. Okay. Yeah. Hello? Are you people there?
Yes, yes, sir.
Okay. So
Yes, sir.
now you pay your attention. It's very important at this point.
Okay,
We
sir.
have completed up to this end. Now what we have to do is from this inner circle, from the inner circle or the circle which is drawn through your minor axis, you have to draw lines which are horizontal. Horizontal lines should be drawn from minor axis circle and vertical lines have to be drawn from the major axis circle. I'll show you how. So take a point 4 dash. From this 4 dash, draw a line parallel to your major axis up to some end in the next, with the same end of 4 where your line intersects the major axis circle at 4, from that point onwards drop a vertical from this 4 such that it intersects the previous drawn line. Okay, what we have done, we have taken a point 4 and we have drawn a line parallel to your major axis up to some extent, and the same 4 from the same line where it is intersecting at 4, we have dropped a vertical where this intersects the previously drawn line at 4 dash. Now this will be your point. This point of intersection is P4. Similarly, from 5 dash, point 5 dash, you take a line, horizontal line. Now that should be intersected with a line which is dropped from point 5. This is vertical that I'm dropping and which intersects the previously drawn point. This point is your P5. Okay. So what I do is, now having understood these 2 points, I'll keep on I'll continuously draw the points, horizontal points first. So from 7, I'm drawing a horizontal line. From point 8, I'm drawing a horizontal line. From 9 oddandi, 9 dash oddu. From 10 dash, I am drawing a horizontal line. From 11 dash, I am drawing a horizontal line. Mali 12 dash ni we are not touching because our ellipse touches here. C point, D point దగ్గర ellipse touch అవుతుంది. So your 1 dash, a horizontal line. From your 2 dash, a horizontal line. Now these lines will be intersected. ఎక్కడి నుంచి intersect అవుతాయండి? 2 dash 1 dash నుంచి తీసుకున్నాం. 1 dash నుంచి intersect అవ్వాలి అంటే we have to drop it from 1. ఎక్కడ? పైన side. Here what we have done, we have dropped it from top to bottom. Here from bottom to top we have to drop it. Similarly, to intersect this 2 dash line from 2, we have to intersect it. Next, from 11, we have to intersect the 11 dash line. Next, from 10, we have to intersect the 10 dash line. Now from point 8, we have to intersect the 8 dash line. From point 7, we have to intersect the 7 dash line. So this point becomes your P2, this becomes your P1, this is your P11, this is your P12, this is your P13, this is your, sorry, this is your P10. This is your P8. This is your P7. వచ్చేసాయి కదండి. Now what next? From A, start joining your points of intersections. P8, P7 and C. Next C నుంచి P5, P4 and P. Next P2, P1 and D. P10, P11 and then join next. So this particular curve is your ellipse. Okay, is this clear?
Yes, sir.
Yes, sir.
So we have completed 2 drawings. We have taken enough time, so leisurely we have completed 2 important drawings of oblong method and concentric circles method in today's class. We have also understood a new method of dividing the line into equal parts. And in the concentric circles, we have also divided the circle into equal parts, though known oldest method, but still, if for some it may be a refreshing method. So this is ways of drawing your ellipse in a special ways. There's one more method of parallelogram method where your rectangle becomes a parallelogram. So how that's done is, generally what you do for rectangle, you draw it this way. How does it become parallelogram? You take some inclination, keep this as constant, and you tilt this with an inclination. So this will be constant. This will be at inclination of 30 degrees. From here at 30 degrees, join them. It becomes a parallelogram. Now construction of your ellipse by oblong method inside this parallelogram becomes your parallelogram method. So for this you have to draw a center, take the center, draw here, take this center, draw a parallel line this way. Now same, divide this, you will have a curve like this. Similarly, you do here, you will have a curve like this. This is your ellipse by parallelogram method. So this you try it in your home. This is similar to your oblong method. Only thing you are doing is you are drawing this in a inclined way. The rectangle becomes a parallelogram here. That's all. So another method left out is the arc method, which we will see in the next class if time permits. So by the next class, all of you have to show the recordings of these 3 drawings. The 3 drawings of general method with these 2 drawings. Total of 5 drawings. All the 5 drawings fairly composed in A4 size sheets, neatly labeled. Okay. When is your next class? It's on Wednesday, right? Hello?
Yes, sir.
Yes, sir.
Yeah. Please keep it ready by next class. And after finishing the rest of the topics in the next class, we will ask you to present the record. Okay. So by this, we will end the class as of now.
Sir, record means the steps, na, sir?
Yeah, with the construction steps.
Sir, where we should write those construction steps? In the A4 size paper or in separate notebook?
In the ruled page, you have to write your construction steps.
Separately in another book.
Yeah, separately in another book. In A4 sheets, you have to draw your drawings.
We should buy record, sir.
No, your record will be given in the college once the college starts. But till then, you make it as a copy. In a ruled paper, you write your construction step, and in A4 size, you draw your drawings. And how can be presented, we will see in the next class. We'll be informing you. Okay.
Yes, sir. Attendance, sir. Attendance.
Yeah, attendance, you post it in the chat box. You copy the diagrams, take a shot of it, and then you can leave the class.